Hi and welcome back to my channel. Today I'm presenting a dyno video of a pro audio amplifier made by Crown, the Crown XLS 5000, which was made by Phonic. This is a powerful and efficient amplifier, 3-step class H, and it's rated 1100 watts into a 8 ohm load and 1800 watts into a 4 ohm load and 2500 watts into a 2 ohm load. I received the amplifier defective. One of the transformers was short, the power switch was defective, and the shaft of the switch was broken. So I decided to make a better one, in my opinion. So I made a cutout in the front of the amplifier and put a better switch inside. Usually there are two inrush current limiters on the board, and the guy who tried to fix the amplifier put some capacitors inside. Totally wrong. I will not understand why this has been done like this. Removed these caps. I soldered the new NTCs in the board. So luckily all the driver transistors, the output transistors were totally okay. I just had to readjust the idle current and that's it. And now I can present a dyno video for you.
The amplifier is connected to the dummy loads. I test with 8 ohms per channel, both channels driven. But before I can start, I need my sound interface and of course a scope. Before I start, I show the difference between testing the amplifier with only one channel or with 2 channels driven. Let's zoom to the scope and start the dyno. The amplifier also has a clip limiter. When the clip LEDs are coming out, the amplifier isn't clipping at the outputs, it's limiting itself to avoid clipping. Continuous power test, 8 ohms per channel, both channels driven, 1 kHz. Until clipping. No clipping possible, it's limiting itself. Clip lights are illuminating slightly. And now I'm measuring the peak voltage. And we have 133.6 volts. The amplifier delivers 1144.4 watts into an 8 ohm load per channel, both channels driven. Continuous power test, 8 ohms per channel, 1 kHz, only one channel driven. Amplifier features 2 power supplies. Limiting. I have a higher peak voltage. Let's calculate with 140 volts. The amplifier delivers 1256.6 watts into an 8 ohm load per channel, one channel driven. Let's have a look at the amplifier's clipping behavior. The second LED from this 3 here is a clip indicator. Signal input is present. Now it shows clipping, but it's, if you see this, clipping is illuminating. Clipping occurs just for a short moment, and now I give full tilt. There's no clipping in the amplifier. This is how the limiter is acting in this amplifier. Both channels driven. Continuous power test, 50 Hz input signal, 8 ohms, both channels driven. There we have distortion. This is the maximum. And I got a peak voltage off. (132 volts). With 50 Hz, the amplifier delivers 1117 watts into an 8 ohm load per channel, both channels driven. Dynamic power test, 1 kHz, 20 cycles into an 8 ohm load, both channels driven. I catch the burst. I see all cycles are at the same voltage level. That's the goal. That's what I want. And I'm going to observe the last cycle. I don't accept if the cycles go down because of limiting or power supply sagging or something like this. So now I'm going to the last cycle, catch one, and we have a peak voltage of 152 volts. The amplifier delivers around 1481 watts into an 8 ohm load per channel, both channels driven. Dynamic power test with 8 cycles.
Limiting. I see some clipping. I don't allow it here. Last cycle also has to be clean. We have also 152 volts. Same output power like with 20 cycles.
Dynamic power test with just one cycle.
We got a peak voltage of,
let's calculate with 163.8 volts. For just 1 millisecond, the amplifier is able to reproduce dynamic power of 1720 watts into an 8 ohm load, both channels driven. Continuous power test 1 kHz into a 4 ohm load, both channels driven.
in this case we have a peak voltage of, I would say, let's calculate with 122 volts.
The amplifier puts out 1908 watts into a 4 ohm load per channel, both channels driven into full power. Continuous power test, but this time with a 50 Hz input signal into a 4 ohm load, both channels driven.
We have a peak voltage of, I would say, let's also calculate with 122 volts.
With 50 Hz, the amplifier is also able to put out 1908 watts into a 4 ohm load per channel, both channels driven. Burst power test with 50 Hz.
We have all cycles at the same voltage level. We go to the peak, top of the waveform. And in this case we have 121.6 volts.
Burst test, 5 cycles, 50 Hz, 100 milliseconds.
We get clipping. It's not easy to adjust it, but we have a peak voltage of 122.4 volts.
The amplifier puts out 1921 watts into a 4 ohm load per channel, both channels driven. Dynamic burst power test, 1 kHz, 20 cycles.
I try to get all the cycles at the same voltage level. That's the case. I go to the last one and check for clipping. Try to increase my input signal. We have clipping. I go back. I think we can take this. Looks okay. And I'm calculating with 132.8 volts.
The amplifier delivers 2261 watts into a 4 ohm load per channel, both channels driven, if testing with a 1 kHz burst input signal and 20 cycles. Dynamic burst power testing, 1 kHz and 8 cycles.
I observe the last one. Oh, we got higher voltage. Clipping, limited. And we got a peak voltage of, let's calculate a little lower, with 140 volts.
The amplifier delivers 2513 watts into a 4 ohm load per channel, both channels driven. Burst power test, 1 kHz, just 1 cycle, output power for just 1 millisecond. And we run into clipping.
I reduce input signal until we have a clean cycle.
That's okay.
I take the peak voltage. Let's calculate with 154.8 volts.
The amplifier is able to put out 3072 watts into a 4 ohm load per channel, both channels driven. Now I'm doing a continuous power test with 1 kHz into a 2 ohm load.
We have a peak voltage of 101.7 volts.
The amplifier puts out 2586 watts into a 2 ohm load. Continuous power test, 1 kHz into a 2 ohm load.
We got a peak voltage of 99 volts.
The amplifier delivers 2450 watts into a 2 ohm load. We have more output power at 50 Hz. Usually you always have more output power at 1 kHz. The limiter is acting and I can't defeat the limiter. That's my problem. Now I'm doing the 50 Hz burst test with 200 milliseconds. I go to the last cycle. Try to increase output power. But we don't get any higher voltage. And the peak voltage is 99 volts. Also in this case the limiter is acting very good, so we can't put out more output power. Burst power test 100 milliseconds. I check the last cycle. That looks okay. We have no clip indication. I would say let's calculate with 100 volts. The amplifier delivers 2500 watts if tested with a 50 Hz burst signal and 100 milliseconds. Dynamic power test 20 cycles, 1 kHz. I catch the burst. And we see we don't have all cycles at the same voltage level, so I go to the last cycle and check the voltage. This is the last cycle. And there we have, let's say, 101.7 volts. Let's say 101 volts. And now I go to the first one. Ah, we have signs of clipping. I'm going to reduce. I'm not cheating here. Now we have, let's say 102.6. Let's calculate with 102. And we can also calculate with 102 volts, all cycles at the same voltage level. That's fine. If tested with 1 kHz and 20 cycles, the amplifier delivers 2601 watts into a 2 ohm load per channel, both channels driven of course. Dynamic power test 1 kHz, 8 cycles this time. Observe the last cycle. Got a peak voltage of 100.8 volts. Try to squeeze out some more. It's possible for a short time to squeeze out a higher voltage. Then I'm triggering the limiter, but we have some kind of distortion. This is limiter acting. So in this case, to get clean output voltage, that's the most I can get out of this amplifier. Amp is limited nicely. Here's the limitation. Not possible to run this amplifier into clipping, and I would say I calculate with 101.7 volts. In this case, the amplifier is also limited to put out 2586 watts into a 2 ohm load per channel, both channels driven. And now the last test. Let's test what the amplifier can put out for just 1 millisecond into a 2 ohm load. Yeah, we get real clipping here. Real clipping. So I reduce now until it looks nicely. There we have a peak voltage of also 101.7 volts. That means the amplifier's output power is limited to around 2600 watts. Here I'm demonstrating the clip behavior. You see on the right channel sometimes the red LED is coming in, but on the scope we have no signs of clipping. I catch it. Clean sine wave signals here. A conservative clip indicator. They are slightly warm, I would say 27 degrees. Now I am going to touch the heatsink. Yeah, they are getting fairly warm. Now the amplifier is running hard into clipping into 2 ohms per channel, both channels driven. Nice amplifier, puts out some real serious output power. I'm impressed.
Thank you very much for watching and see you next time. Bye bye.